In today's video, I wanted to talk a little bit about what does tuning mean. I think this is really important for two reasons. The first is that I feel that our industry has evolved enough over the past 10 years around energy efficiency that we need to reconsider how we tune systems. The second part is the word tuning comes up a lot in mechanical specifications, and the word tuning comes up a lot in BMS maintenance proposals or BMS fee proposals or maintenance contracts. So if we change our understanding of what tuning means and the functions that we provide, there could be a flow-on improvement through the construction phase of projects as you do the commissioning phase and the tuning phase, and there could be a flow-on improvement through 20 years of BMS maintenance. So when those service technicians arrive at site and they're doing tuning, they might do something different to what they normally did. Now, I know it doesn't sound very exciting, but just bear with me, this is really important. If you ask a BMS engineer, what does tuning mean? They will tell you that tuning is the adjustment of the PID parameters in a control loop to result in stable control of the process variable. Temperature, pressure, humidity, CO2, volume, velocity, whatever it is. So after you've tuned those PID parameters, although usually it's just the PI parameters in our industry, as that outside air temperature coming into the building is changing, and as the load is changing and the sun around the glass is moving, and our energy efficiency projects are adjusting temperature set points and pressure set points, tuning means that as those changes happen, the outputs move in a controlled, stable, smooth method, and the process variables react. So tuning is adjusting the PR parameters so we have reliable, stable control. Now, that is technically correct. I'm not challenging that. That's what tuning has been since the start of our industry. But in my opinion, tuning PR loops only needs to be done once. You should do it after commissioning in the construction phase. If that got compressed out completely, which it does on every single job, there's no time to commission it. How's there time to tune it? At least then in the first year of maintenance, you could go around and double check and just tune all the PR loops. But after that, we should not be tuning PR loops, ongoing. So, in 5 years' time, if you're a service technician and you come to site and there's the plan on the wall, it says, in February, we're going to do tuning to AHUs 1, 2, and 3. Going to AHUs 1, 2, and 3 and tuning the PR loops, in my opinion, provides very little value to the end user. We'd be much better off using those precious maintenance hours to do something that actually results in value to the end user and the client, which is usually energy efficiency type stuff. So I'm proposing that tuning means something else. And in my opinion, tuning means this. Depending on the type of building you have, and depending on the client that you have, and depending on what their priorities are, tuning means the adjustment of our control strategies from comfort control towards energy efficiency control. Now, those last two videos just touched on that, the chilled water supply temperature reset and the condenser water temperature reset. Those are energy efficient control strategies where tuning is the adjustment of how aggressively we're going to push those boundaries of reducing the condenser water temperature and how aggressively we're going to raise the chill water temperature. Plus, there's a whole bunch of other things that we'll be doing. So if you're in a premium grade building or an A grade building and the client really wants to improve their neighbors rating up to 5 stars or 5.5 stars, and they're going to do that because if the building has a higher energy efficiency rating, then they can attract higher profile tenants who will pay higher rent. Or if they have higher profile tenants already, they can retain them. Here in Australia, a lot of government departments, they won't go into buildings under 5-star neighbors rating. So if you have a poor neighbors rating or a poor building energy efficiency rating, you can't attract the highest paying tenants. So on premium grade, A grade office towers, those clients will spend a lot of money to raise their energy efficiency rating. So on those buildings, we're going to aggressively tune our control strategies from comfort control. We're going to push as hard as we can, all that effort to try and get the maximum energy efficiency out of our control systems. That's for an office tower. If you're in a hospital, they might not care as much about their building's energy efficiency rating, but they might have $1 million electricity bill. So in the hospital, we might just push halfway. We're not pushing all the way to here like the office tower. We're going to push and tune our energy efficient control strategies away from comfort out to over here. If you're in a data center, maybe where the priority is resilience of their control system, or the reliability or redundancy of the control system, we might just push a little bit. Like they do care. Data centers still want to have good PUE, power usage effectiveness. So they care about energy efficiency, maybe not as much as the office does. So I'm proposing that tuning should mean the effort that we adjust our optimized control strategies away from comfort control towards energy efficiency, and how aggressively we do that depends on the building, our owner, their budget, what their priorities are. So guys, if you enjoyed that video or learned something, please like and subscribe, and I will see you next week.